Hello, chemistry students. Today we're going to talk about the classification of matter. So what is matter? Matter is anything that has mass and takes up space or has volume. Now when we classify matter, we classify it into two basic things. And the first question we're going to ask ourselves is, can it be physically separated? For example, through filtration, if you filter it and you can separate it into two or more different things, or evaporation. Another way to separate it is if you just pick it out by your hands. And if the answer to that is yes, then it is a mixture. If the answer to that is no, then it is a pure substance. Now let's go over here and look at the mixture. We can classify that into two different substances as well. And the question we're going to ask ourselves when we determine that it is a mixture is the composition uniform throughout? Does it look the same? Is it all indistinguishable from each other? And if the answer to that is yes, then it is a homogeneous mixture or a homogeneous mixture. If the answer is no, then it is a heterogeneous mixture. Now let's get an example right here. This is called the Tyndall effect, and there's a flashlight over here, and we're shining that flashlight through these two beakers of substances. Now, if you notice on this beaker on the right, you can't see the light in between. That would be a homogeneous mixture because you cannot distinguish it. So that would go right down here. Now here, if you shine a flashlight, you can see particles. You can see the light going through. So those little particles in there are reflecting the light, which is why you can see that beam of light. And if that's the case, then that means you can distinguish the particles in there, and that would be a heterogeneous mixture. Now let's go over to the pure substance. We're going to ask ourselves this question: is it made up of only one type of atom on the periodic table? And if the answer to that is no, then it is a compound. An example of a compound is water, H2O, because hydrogen, H, is one element on the periodic table, and oxygen, O, is a different element on the periodic table, and they are bonded together. If the answer to the question, is it made up of only one type of atom on the periodic table, yes, then it is an element. So hydrogen gas would be an element. Oxygen gas would be an element. Pure substances. They are uniform, unchanging composition. Every sample of a pure substance has exactly the same characteristic properties and composition. For instance, a pure substance is water. Every single molecule of water has the same characteristic properties and composition. If our example is hydrogen gas, every single molecule of gas has the same characteristic properties. Pure substances exist as either elements or compounds. An example of an element would be iron. They are found on the periodic table. They cannot be separated into simpler substances by physical or chemical means, and it takes a nuclear reaction to break them apart. A compound, an example, would be baking soda. And here's the formula for baking soda. Combinations of two or more elements that are chemically bonded. Here's an element, sodium. Here's a different element, hydrogen. A different element, carbon. And a different element, oxygen. So there are 4 different elements in here. A chemical change is required to combine these elements or to separate this compound back into its original elements. Mixtures is a combination of 2 or more pure substances. So it's 2 or more elements, 2 or more compounds, 1 element in a compound. And each pure substance retains its individual chemical properties. So let's say if we talk about salt water, we can evaporate this and we can get our salt all by itself and our water as a gas. But the water still acts like water and the salt still acts like salt. A heterogeneous mixture, an example of that would be dirt. You can see the individual particles in here and you can pick them out. It is not uniform throughout. You can see the differences. They're usually made of very large molecules. Homogeneous mixtures. These are examples of homogeneous mixtures. Sodas, You can look through here and they look the same all the way throughout. Even if you put it under a stereoscope or a microscope, it would look the same. They are uniform throughout. They are also called solutions, and they're made of very small molecules. Now this has sugar, whoops, I almost put salt, sugar, water, and usually dye. That's D-Y-E. So this is a mixture of at least these three things right here, sugar, water, and dye for these sodas. So it would be a homogeneous mixture because we cannot distinguish the sugar from the water. And remember, they're usually solutions. I would like for you to practice now. Pause the video and do example 1. Check your answers. If you have any questions, please mark it and ask me in class.